Hello everyone. So this is section 10.2 part 2. Okay. So this notes is more of theory, and we will not have section 10.3 and 10.4 in this semester, okay? And you will not see any problems on those sections in your quiz, neither in your MLM assignments. If you do so, you can email me and I can remove those questions for you. Okay? Okay. So let's get started. This is about correlation and regression, and we are mainly concentrating on regression in this section. Now, marginal change. So what does that mean? That means if you are changing one variable, okay, if you're changing one variable by 1 unit or like 1%, then the other variable also changes. So that is called as marginal change. So you have an example here. So you would have done this example in the part 1. So what does this tell you? So now let's say that the slope value is 3.22. Okay. Now, when I say slope, that means if you are increasing 1 centimeter of the shoe length. So in this example, X was the shoe length, X was the shoe length, and Y was the height, right? Now, if you increase the shoe length by 1 centimeter, the Y will increase by 3.22 centimeter. So that's the meaning of slope. Okay. Now let's say I told you that slope equal to 3.22, right? This one. Slope is equal to 3.22. The meaning is if I increase x by 1 centimeter, y increases by 3.22 centimeter. Okay. Now another example. Let's say your slope is 15 now, and you have example in this way. Your x is your final grade, your final exam grade, and y is your overall score or grade. Okay. Now if I increase x by 1 point, then your overall grade, that is y, increases by 15 points. Okay, so that's the meaning of slope. Okay, next is outlier. You all know that outlier is a point which lies far away from the other data points. Likewise, we also have the influential point. The meaning is same as your outlier, but this is defined, or it is used when you are using a paired data. So what do you mean by paired data? For example, you have a plot like this, scatter plot, and you have some points data. Okay, now let's say that this position is 2, 2. Then how do you write your ordered pair? You write it as 2, 2, x, y. Okay, now for example, let's say all these points are here. Okay, and this is your outlier. So this point is your outlier, and the ordered pair of the outlier is called as influential point. influential point. Okay, and these points they strongly affect the regression line, and we will see how. Okay, now we have two examples here. Now this example we did in part 1. Okay, now let's take a look at the diagram here. So this both are your scatter plot diagram, right? Now take a look at the first diagram here. So this is a straight line and data points are almost following the straight line. So there is nothing weird in this. But when it comes to second picture, you have the same value, everything is same. Okay, nothing changes, everything is same compared to 1 and 2. Only change is that the presence of the outlier or the influential point in this example. Okay, suppose there is a point here which is far away from the other data points. You can see the difference of the diagram, right? Here it was increasing and it was a linear relationship. Here also you have a straight line, but you have a horizontal straight line. So you can easily see the changes between the first graph and the second graph due to the outlier or the influential point. Okay, the line changes dramatically if you have an influential point in your data set, and this proves that the regression line will be strongly affected if there is a presence of outlier. Okay, now residuals. So what are residuals? Now you have a pair of values, that is x and y. So your residual is the difference between the observed value and the predicted value. So it is more often like your exact answer and the answer you are going to find. Okay. Okay. So let's see with an example. Now this is your graph, and now this line is your regression line. You all know that, right? Now this is nothing but your observed data. Right? These data points which you see here are the observed data points. Okay. Now you also have the regression equation. Now if you observe clearly, I want my answer to come near the straight line because that's the answer we need. So that's like an observed data, that's like a predicted data. So we need our answer to come near the straight line. Okay, now let's say okay, now how did I get 5 here? That is nothing but you need to subtract your observed data with the predicted value. Okay, now if you can see, this is the predicted data, sorry, observed data, right? This is the observed data, which is let's say it's like between 8 and 10, so let's take it as 9. 9 minus, and here we have maybe near 4, maybe near 4. Let's take near 4. Now this was your observed and this was your predicted. So 4 minus 9 was minus because the line is predicted, and the data points which you see there is observed data points. Right? Now, in the same way here, how can we do? Let's draw a straight line from here because I want to know which point is this. So let's go there. And here, the same thing, just draw a straight line from there to there. Now, if you minus these 2 points, you have to get that. Okay. In the same way, you can find these 2 points as well. So this is how you find the residual plots. Least square property. So what is least square? So this is a method. It is a method to find the line of best fit. Line of best fit, that is your regression line for a set of data points. So you're going to find a line best fit for those data points. And how can you find that? By minimizing the sum of squares of the residual. Okay, so here you saw that the residual from this point to this point was how much? 5, right? The 5 was the difference between these two data points. So it was 5 points away from the exact answer. So I want my data point to reach this line, but I want to minimize this 5. Okay, so how can I do that? You have to use least square method. Okay, so that's one importance of this. Now, this is also used to predict the behavior of dependent variable. Dependent variable. Residual plots are nothing but a scatter plot, which also have x and y values like your scatter plot, but only difference is this y is replaced with residual values. Okay, and what is the formula for that? That is y minus y cap. Y cap is the predicted value of y. Okay, so if you represent x and here you have a residual points, that means this plot is called residual plot. And we have few properties of that here, and like this points will tell you whether it's a good model or not. Okay, like we use scatter plot to predict whether the model is good or not. We also use residual plot for the same purpose. Okay, now we have a small example here. Now they say that the first sample values are 4.5. It is substituted into the regression equation, plug in to the regression equation here, and what do you get? You get y cap, right? If you put 4.5 in the x position, because that's the given value for x, you get y cap as 7.84. Okay, now but the actual value of y has to be 5.5. Okay, now the exact answer of y must be 5.5 for x equal to 4.5, but the value which you predicted, right, predicted value, I call that as y cap, was 7.84 something for the same value of x, right? Now, how do you find the difference between these 2 points? What is the amount of difference? You do residual. Okay, so residual is simply exact minus predicted, that is 5.5 minus 7.84, that will give you minus 2.34. So there is 2.3 points difference, or 2 points difference between the exact and the predicted value. Okay, this is how you find the residual point. Now let me plot those points in the residual plot. Okay, now this 4.5 and minus 2.34. Now what is minus 2.34? It's a residual x comma y minus y cap. So that is why we call this as residual plot. X is 4.5, so somewhere here, and your y is minus 2.3. So this is one of your residual point, a point which you found. Likewise, we find residuals for each and every point which is present here. Okay. Now, you have certain examples here, and this will help you to find whether it's a good model or not. Now, the first graph is a good model. First graph is a good model because if you still go on, like predicting the values, you can see the points are going near the straight line. So I want the points to follow the straight line, right? We want the points, data points to follow the straight line. So we can see that the points are somewhat coming near to the line. So this is first plot. So I say this is a good model. Now, second, you have a straight line. Now I know that like 1, 2, 3, 4, 5, 6, 7, 8, 9, all these points are almost near to the straight line, right? So now, but I will not say this is a good model. Why? Because no matter how many times you do the regression, this will not follow the straight line because it already has a pattern, right? It already has a pattern. So it is like, let's say that you know how to go from momentum to campus, okay? And somebody comes and tell you that follow my way so that I can take you to the campus. What do? You just follow the way you are going, right? So you will, no matter who comes, but you will just follow the same route always from momentum, for example, momentum to campus, right? So that's your pattern. So you're not going to follow the other pattern, whichever comes. So when you already have, or when you already know the route, know the way how to go there, then you're not going to follow other route, right? That's what happening here. When there is a pattern, a data points are following, they are not going to encourage other new patterns. So this is not a good model because it will not form a straight line because you have a pattern. So even if we omit this point, let's imagine we don't have that point, even though this is forming like a zigzag motion, right? Okay. So, and that is why it's not a good model. That's okay. Coming to the third point, third graph. Now you can see that compared to the first plot here, you can see most of the data points are on the straight line and it's following, and I don't see any patterns here, right? But still they say it's not a good model. That's because let's let's join these points, and one is going in this way and another is going in this way. Now you can see the pattern is getting wider and wider, right? Wider and wider as you go on. As you go on, it is becoming wider and wider, right? And that is why this is not a good model. Okay? So that will complete your chapter 10. So this is all about your chapter 10. As I said you, we will not be studying section 10.3 and 10.4, but we will learn about few concepts based on that, and you will find problems. Okay, so like in lab 10, you studied about finding the correction interval, PI values, right? And also the point estimate. So those concepts you have to learn, and you will find problems related to those concepts in your quiz and your MLM assignments. Okay, so to do that, you use a software called as a Star Crunch. Okay, so the details of that is already been posted. I can show you where is that. Now, if you go to my 003 section, my name there, and then just scroll down here, and also I will be posting it here in two things. So okay, click on this and just scroll down, and here you have chapter 10 notes. We completed this part 1, part 2 is done. So 10.3, you don't have to study everything, but you have few concepts um, which you have to concentrate on. And we already have a notes here. It's like a presentation. So if you do not understand this notes, we also have a videos here. Okay, these are the video links. Just click on this video and that will take you to the link. So this will explain you how to find the variation using start crunch. Okay, stat crunch. So we have 4 videos in the same way. You can use TI-83 also, and you can also use StatCrunch. So whichever you find easy, you can use them. Okay, but remember, if you still have any difficulties doing those problems, you can come to me. You can attend in the office hours either through WebEx or in person, and I can help you with that. Okay, so this will complete your chapter 10 completely, and I will be recording chapter 11 and 12 videos and will be posting it soon. Okay, see you on Monday.